Hello and welcome back to Elementary Algebra. We are starting chapter 3, so this is 3.1 on Introduction to Graphing. So there is a lot of stuff that we want to talk about today. There are a lot of words and terminology to learn. I am going to suggest to all of you to have proper notebook for math. That's a suggestion, which is the one with squares, and so that your graphs look straight and you know what goes where. Also, I would suggest you to have a straight edge, which is you can get it in a dollar store, but if you can also make it out of anything that is straight, piece of wood, book cover, whatever. You can use to draw straight lines because that is going to be very important for our chapter 3. Now, clearly, when you draw the line, you can try to draw the line with a, straight, just a hand, or use the straight edge. And the two lines that I have here, clearly the one on top is the one that is freehand, and the one on the bottom is the straight line using the straight edge, which I use to draw. So it's important to have these things straight. We'll see later because you will use them to read information from the graph. But so in a preparation for this, if you could find some graph paper. I mean, the proper thing to do for math course is to buy a square notebook, right? A square ruled notebook, and then obviously pencil, eraser, and a straight edge. So if you have those four things, you should be good to go. Now, obviously, for better education, there is a protractor and compass and a few other things that you can also, but usually, a lot of instructors gave up on that long time ago, unfortunately, because education is terrible. So, what are we going to do? We are going to understand graphs. We are going to understand the meaning of, let's say, whatever graph. You can take a look at the graph that, let's say, a stock market graph that goes like this, and this is 9, this is 10, this is 11, this is noon, this is 1, this is 2, this is 3, this is 4. See, that's terrible because I should have ended at 4 because the stock market closes at 4. So we're going to close right there. Okay. So what this shows here is a graph. I mean, they're usually much busier than this. So let's just, no. Evil thing, come on. The graphs are usually much busier than this, so let's just go and do this thing. Let's say like that. All right. And this is going to be money, and this is obviously time. This is your 9 a.m. and this is your 4 p.m. So these are intervals of 1 hour. This is the opening cost and the closing cost. So we want to understand, our goal is to understand how to read graphs so that we can use them to read data from the news. If something is presented on the, as a data point, and we want to understand, also to understand if you are interested in investing, right? You want to know whether you're gaining or losing money, and whole bunch of stuff. So graphs are very useful to us because we visually get to see if the values are going up or going down. And we'll see later on that when the line looks like this, the value goes up, and when the line looks like that, it goes down. And we'll describe that to positive and negative slope later on, which brings us a lot more input. But I just wanted to, quickly show this this idea of like, let's say, a stock market graph of some kind, but literally anything else. We can use anything else. So what are the things that we need to learn? Well, we need to learn the vocabulary of this first, and then we can go and play these games. So what I'm going to do now is I'm going to steal the graph from here and place it down. There we go. And this would be the standard two-dimensional XY coordinate system. So this is not a graph. This is XY coordinate system. So XY coordinate system. And I'll just put in not a graph. Graph will be points and lines that we put on it. This is like a setup only for, right? If you had two boxers, right, in a boxing ring, you would call that a box match, right? But if there was no boxers inside, you wouldn't call it a boxing match. You would just call it a boxing ring, right? So this is the same deal, right? We are going to play the game inside of this, right? And it has its name. Now, graph is like the boxers. Graph is what you put inside of this, which are the lines or the points or whatever else. So this is called the coordinate system. This one over here is called the x-axis. And this one is called the y-axis. And the point in the middle where they intersect is called the origin. So these are the words that we want to learn when we start dealing with this. So XY coordinate system, and you're thinking of it as a boxing ring, right? Or the hockey or a football field or a baseball field, right? Without players and without the game, it's just a field or a boxing ring or something like that, right? That's what it is. And then when we put the graph on it, when we put the lines and points, it becomes a graph, in which case, right, you get the baseball game, you get the football game, you get, right, all of these kind of things when you involve players and strategy and everything else that brings to the table. So that's the first part. Now, each one of these has 4 quadrants, and we use Roman numerals to denote those 4 quadrants. 4 quadrants meaning you have 4 parts, like four rooms, 4 compartments, whatever you want to say. And this one over here is called first quadrant. This is the second quadrant, so we have 2 lines. This is the third quadrant. And finally, the fourth quadrant. So now we understand that there are 4 different quadrants, and they have their names, and we put those names in a counterclockwise position. So counterclockwise orientation, which means this way, right? So 1, 2, 3, 4. Now, those of you who never studied before Roman numerals, so you're not confused with this, single line is 1, 2 lines is 2, 3 lines is 3, and now when you write it this way is 4, because this thing alone is 5. Now, people sometimes don't put these lines, so it just looks like letters I and V and so on, but it's not I and V, right? In the old times, these were the letters. Those of you going to number systems will learn that Mayans had their own letters, Egyptians had their own, numbers. Mayans had their own numbers, Chinese had their own numbers, Egyptian had their own numbers, there are Babylonian numbers as well, right? And then you have the Roman numbers, which are called Roman numerals, and then you get the ones that we use. Those are called Hindu Arabic. So when you look at these numbers, right, Eventually you'll get to this being equal to 10, right? And you have L and M and D and C, right? C is 100 and so on. So it's a whole bunch of, they're all are Latin letters, but actually they represent the value. So that's the Roman numerals. And as I said, the ones that we are using, these guys, they're called Hindu Arabic letters, and they came from those parts. So now what we have here is we are using Roman numerals 1, 2, 3, and 4 to denote values of quadrants. So you can find the point in quadrant 1 or quadrant 3, depending where the point lands. And we'll see how the whole thing works. Now I'm going to jump into talking about points and locations. So let's put another one of these coordinate systems, right? So this is going to be a coordinate system. It's not a graph until we put something on it. So now I have my, again, x and y coordinate axes. They're always the x and the y. And what these are just those number lines that you have seen earlier in chapter 2 for inequalities. And, so number line is like, you can also think of a measuring tape, right? It goes from 0 to 25 feet. 1, 2, 3, 4, 5, 6, 7, right? And it has the smaller divisions. This is the same thing, right? It is the number line, and the number line is going to contain all of these numbers. 1, 2, 3, 4, 5, 6, 7, going to something that we call positive infinity, meaning the values go forever and they never ever stop. So this guy is called infinity. We are not going to use this in this course, but it's cool to, it's cool to see it when it's, when it's there. So now for your numbers axis, right, you have the values you have a 0, and then you have values to the left, and those would be negative numbers. So -1, -2, -3, -4. Uh-oh, we are starting the overheating already. We haven't been in it 15 minutes even. Okay, I have to go get the cooling pad. All right, so now this is just a basic number line, like the one that you use to graph your values, right? You put your open or closed circle and then go left or right, whatever. There was your 2.6 graphing. Hopefully you already did the homework and know how to do that stuff. Now the y-axis, oh, there's a negative infinity on this side. Yeah, it's becoming impossible. I have to go get the thing. I'll be back in 2 seconds. So the y-axis will also be a number line with positive numbers up and negative numbers down. So if you want to fill that in by the time I come back. So we have positive numbers going up. So guys, y-axis and x-axis are the same concept. It's just a number line. And they are, both of those number lines are the same number line that have all of the numbers. And then we turn one of them at 90 degrees and we attach them at zeros so that 0 of one matches the 0 of the other one, which creates the origin. And now we have the same thing for x, we have for y. All of the positive numbers now will actually go up, and all of the negative numbers will go down. Miss the negatives there. All right. Now, you also have the positive infinity on top for y-axis and negative infinity on the bottom for y-axis. So this is not going to change. You still have your first quadrant, second quadrant, third quadrant, and fourth quadrant. That doesn't change, right? All we did is we just made sure that we added these numbers. So what is this good for? Well, it's good to show two-dimensional location. We can place a point on this grid and create graph. So I can put a point anywhere. Let's say it's right here. And then we can find its location on this surface by looking at what we call coordinates. So when you hear the word coordinates, that means a location, numbers that show location of the point. So if you carefully look over here, it has 5 as x and it has 3 as y. So this point here will be given as 5 for x and 3 for y. So our two-dimensional points, because you have two values there, 2 dimensions, 2 values, 3 dimensions, 3 values, and so on, is always given as x, comma, y. So x coordinate first, and then y coordinate. You can also have a negative value, right? Let's say you have this point here. That one is going to have negative 4 as x and positive 1 as y. So we'll call this negative 4 on x. Always list x first. And then we have positive 1 on this one. And we have our location. Now, once I started talking about coordinates and locations, did anyone think GPS? Because that is correct thing to think, right? Even though the planet is round, we can make a graphical representation of its surface flat, which some people mistakenly, looking at the map, think that the Earth as a planet is flat, which is ridiculous. The Earth is round, it's a ball, and then we can make flat maps. Just like if you take a basketball and you cut it with a knife, and then you make it flat, right? You step on it until you make it flat. You can do that, and that's how you make a map. So now if you have a map, that map will have roads, and you can find the locations, right, of those roads, and you can create the grid with lines and points, and you can have a GPS. You program locations in which there are roads for people to drive, locations that are destinations, which are restaurants, gas stations, and all that kind of stuff. It's a lot of data, right? And all of that is bouncing off of the satellite. So you have all of the stuff you need, right, to go to point A to point B without including your brain in that operation anymore. Right? Before you had to carry a map and pay attention, and now you just listen to turn left here, right? And then you turn left, and that's it. All right. So far we learned that this is called the coordinate system. We learned there are 4 quadrants because there are 4 parts. We learned that it's a counterclockwise direction to count them. We learned the origin, x-axis, y-axis. We learned that both of these axes, x and y-axis, are just number lines with all of the numbers present, including fractions, decimals, right? And they go to infinity. So when you cross them together, they would go to infinity. And once you have these number lines with these numbers and divisions, you can go in and find these locations, which are called points. So now, when you have a point, it's going to be x and a y, and then these two puppies here are called coordinates. And we can say location, right? It's a location on that surface. So what do we do with all of this now information? Well, we use it to graph and understand various phenomena in nature. So some of you might be going eventually for business, right? Might take economics class, learn about supply and demand curve, and that is something that we will also have these graphs. I'll show an example of that as well, and then setting what is called the equilibrium price and all of that kind of stuff. There's a lot of cool things that you can do and get on board with business and maintain your own business, right? And so on. But first, you have to know the basics of mathematics so that you can be successful in these things. So now I'm going to draw the coordinate system here, something that would, resemble your homework. They might ask you to state the coordinates of this point and say which quadrant it's in. So you'll say, okay, so to the left I have negative numbers on the number line. So coordinates and the quadrant. So your homework will have a question like that, or 2 or 3. And then you understand, you know that the negative numbers go to the left and the negative numbers go down. You also know that you always list x first. So when I look at this point, it's going to be -4, -2. Because x is listed first, y is listed second, and you can see that these lines point towards -4 and -2. Now, quadrant. Let's not forget that. So quadrant, this is 1, this is 2, then this must be 3, and then that's a 4 at the end. So it is quadrant 3. So it's a third quadrant of the 4. And again, that's important for quickly locating stuff. Guys, we use this a lot. There is mission control. You know what? I'm going to show you how complicated life gets. I don't think it's gonna be busy. Actually, I should check before. I'm checking on my desktop before I show it to you. Oh, it's nothing. I guess still COVID. But yeah, it's nothing. So I was ready to show you some Amazon stock and stuff, but first let's go and get this. So it's called Flight Radar 24, which is the live tracking for airplanes. I forgot that you guys, there we go. Can you see this?
Yeah.
All right, so this is nothing. This used to be 10 times, 100 times more planes. Look how many airplanes around, right? And these are just commercial flights. They're on airplanes, they're on airports, they're flying all over the place. And if you zoom out and load more, right, you have to make sure that these airplanes, right, are not hitting each other, right? So they have to be on different heights and different elevation, and they go different directions, right? Some of them go across the ocean to Europe. If you take a look, let's take a look. Oh, there we go, finally loaded. Do we see the amount of airplanes on the east coast of United States going towards the center?
Yeah.
Right? That's a lot of planes. And let me slide to Europe, see if Europe is busy. Here's Spain, France, Italy. There we go. So, yep, right. Now, way more planes in the air before the COVID thing started. Um, each one of these planes is assigned XY coordinate location, right? And they also assign another one, Z, for height of it, right? And then computers and people are keeping track of every single one of these. Every single one of these. So this is what the mission control does, right? And when you are good with these graphs and you're good with points and coordinates, right, you can get a job in mission control, right? Tracking the airplanes and making sure that there are no collisions and so on. Now, that's a lot of planes in the air at one time, and they don't track those small planes, from those small airports that are like local in, one in Hillsborough and Bridgewater have, a whole bunch of these small airports. They don't track those. Those stay under 3,000 feet and, usually about 1,200, 1,500 feet. Those are not tracked. These are all big planes that have, 100 passengers, 200, 300 passengers, and so on. This also doesn't track military planes. It doesn't track Air Force One. So it just tracks commercial flights. I don't think they even track the UPS, FedEx, right, Walmart and Amazon planes. Like none of that stuff. I think these are only commercial flights with passengers, with people. So and this is live, right? So you can actually click on each one of these planes. It gives you the info on when they're going to land and where they're going, and the height and the speed, all of this stuff. And if you pay money, you can actually, they have cameras, you can see what the plane sees underneath and on the ground. So that's a really cool feature. All right, going back to class. So you are able to learn and see these things, um, and where they're used. But first you have to learn about coordinate system and to be very good and very proficient in um, working these things out. So the first part is for us to um, do that, and then we can now start making graphs for different things. So what I want to do now is I want to show, for instance, I want to show the population of the world, and let's start. Let's come up with the data. We're going to ask Google to give us that data. So let's start in 1970, and then every 10 years pick up the population. That's not going to be that many years, right? And we are now in 2020, so we're going to conclude. So this is a year, which will actually be our x variable, and then we'll have the population, which is going to be our y variable. So now I have to go and ask Google on the world population in 1970. And that is going to come up as 3.68, so call it 3.7 billion. Now, they're all going to be in billion, obviously, so we're not going to write this billion every time. 80 is going to be 4.4. 1990 is 5.3 billion. Then we have the 2000, which is 6.1 billion. Then we have 2010, which is 6.9 billion. And then we have 2020, which is 7.6, I believe. 2020, which, 7.8 billion. So this is the human population worldwide, right? Population Y. So human population worldwide. So United States is the third country for the largest population. Largest one is China, followed by India, both of which should have over 1.5 billion people, which is roughly 5 times more than what we have. And we are third, right? Some other large countries in the top 10 would be Pakistan, Indonesia, Brazil, Germany, and so Mexico, right? So those would be some of the other countries that have very high population in top 10. So now, what I can do with this information is I can draw the graph and I can connect these points with a line. I mean, I see that the numbers are growing. I see that the population is growing. So I can do that with a chart. But I also have to do mentally more work, because I look at 3.7 and then realize that 4.4 is bigger and 5.3 is bigger and 6.1 is bigger, right? So it's not impossible, but it takes effort. Now, what we can do is we can draw, and we don't need negative numbers, so I'm not going to go and draw negative parts here. I'm going to draw this, and maybe every 1970, 1980, 1990, 2000, 2010, 2020, and this is our time axis, but that's our x-axis. Let's just call it x. I called it x earlier. Now, for my population over here, right, we have between 3.7 and 7.8. I can put this little break in a graph here, showing that I'm not starting at 0. And I can put 3, 4, 5, 6. It's not going to be enough. 7, 8. There we go. And this is our y, which is population. Now, where is 3.7? Well, between 3 and 4. We see where 3 is. So this is 3.5. So 3.7 has to be there. We go across to 1.7. Next one is at 4.4. 4.4 is a little bit less than 4.5. We go across and make another point. 5.3 is at 5 and then almost like halfway, a little bit more than halfway, but less than 4. So we go to 1990, right there. 2000 is 6.1. So 2000, 6.1, that's just barely over the line. 6.9, that's going to be barely under the line, right? Because the next one is 7. And then we have 7.8, which would be right here. So what you can see here is that you can connect this with a line like this. And when we look at these data, we see that the population rapidly increases. And what you can also see is that in the last right? 50 years, we doubled the population of humans on Earth, right? Because 3.7 times 2 is 7.4. We have 7.8, so that's more than double in 50 years. And the rate at which we are doubling is getting faster and faster. Now, obviously, that's due to medication, right? And raising people out of poverty at record levels. So we have never had bigger economic growth worldwide than today. So the present time is always the best time to live in because it is the most advanced time with least amount of poverty um, at any given time in history. Like you really don't want to go, 70 years ago there was a Second World War, right? And then 90 years ago there was a depression, and then 100 years ago there was the First World War, 115 years ago, First World War, and then prior to that all the plagues and polio and all of that stuff, going back to 1500s in Europe, where it was terrible. So all of the time in history was really awful, and it was literally in the last like 40 years maybe that we kind of started living okayish. And like today is the best day on the planet ever. That's the thing that in terms of poverty, energy consumption, and all of that stuff. Now we do have more people, which means more resources, more energy, which will eventually reach the cap. Now those lectures are all in pre-calc, calc, and differential equations. Now we're learning how to put the points down to see that the trend is going up because the numbers are going up, meaning that the population is going up. Any questions, concerns about points?
No.
Right. So the next part will be to take a look at one that it's maybe losing the value in some sense. So you can also have the data that will show how the data is trending down. So problem in the book 49 on infant mortality rate. So when you take a look at infant mortality rate, they give again from 1970 there was 20 per 1,000 born. So 20 per 1,000 births. Then we have 1980, 1990, 2000, 2010. Obviously, the numbers for 2020 are not out because we are in 2020. But all of these numbers that I'm going to write are per 1,000 babies born. And again, going back that we live in the best times possible is because mortality rate is also much lower. In the past, 100 years ago, right, people would have 8 kids, hoping that 3 of them will live, right, to go on. And, then the Second World War shows up. So the numbers are 20, then the next one is 13, then the next one is 9, then the next one is 7, and the 2000 is 6. So this is the meaning of this data is that in 2010, 6 out of 1,000 babies born died. That's the data. So all of this is the same, and we see that that went from 20 down to 6. Now that's us looking at the data in the chart. We can the table of values, but we can also graph that the same way we did before, and then we can look at the values. So here we go with 70, 80, 90, 2000, and 2010. And over here, I'm going to have, let's go like this, 5, 10, 15, 20. So these are, this is the rate of deaths per thousand on the y-axis, and on the x-axis is again year, right, that you're collecting the data. So we start with the 1970 with the highest infant mortality rate, which is there. Then we drop down to 13 in 80s. So 13 would be right here. Then we drop down to 9 in the 90s. Then you drop down to 7, which is there, 7. And then we drop down to 6. It has to be just above that line, because if you draw it on the line, it's 5. But if you draw it the whole point above the line, it's 6. And if you draw the line through these data points, you see that this is a decrease. So what we learned now is that when the line goes this way is increase, also growth. And when the line looks like this, it's decrease, also known as decay. And there are graphs later on in mathematics that you learn, right, with population growth. And then you can also talk about decay, where you have mass decay, which you can use to compute how fast would plastic decompose, right, how long, which is tens of thousands of years, right, and so on. So decay of radioactive elements and plastic, and pretty much garbage decay for environmental studies and so on. So all of those things are computed and understood very well in sciences, and we know exactly what it takes for these from scientific point of view, right? We know how long will it take for things to decay. So that's the lecture. I mean, we don't have any computing here to do. You need to be able to read the point from the graph and locate the quadrant. You need to be able to graph the point, like I just did in last two examples, given data. And then, the question might ask you to connect with a line, might not. And then question might ask you to, take a look at the trend and say, the values are rising or they're falling, because that's the reason why we do these graphs, right? We do the graph, we draw the graph so that we can see quickly, right, without analyzing every single number. We can just see if the line goes up or the line goes down.
I have a question.
Yes.
Is there any particular reason that quadrant 1 is on the right and it moves left to 2?
Yes, there is. The reason here is well, first of all, in mathematics, we measure all of the numbers. Everything is measured counterclockwise. The clocks
Okay.
are the ones that actually go backwards from everything else, because they are actually the latest. If I told you that the clocks are only 600 years old and most of this stuff is over 2,000 years old, then you would understand. But also the first quadrant is where you have both numbers to be positive. So it makes sense to start there, right? The first quadrant, as you can take a look at this point here, is 5, 3, so x and y are both positive. The other three quadrants have something or both of them negative. Quadrant 3 has all negative, right? So you can see that, this point here is -2, -3. So both numbers are negative there. So that's why we start in the upper right, and then counterclockwise is everything in mathematics is measured counterclockwise. Angles, positive angles later on will be in that direction and everything else. So there you go.
Thank you.
Cool. Any other questions, concerns regarding this lecture?
No.
No? All right, then.
Pretty straightforward.
Bye.